today we're going to start with the decoder. The reason is, well, for the compressor, we actually started with the encoder, so it makes sense that for the decompressor, we do the same. And like with the encoder, the first decoder we're going to write is the mock decoder. Means a decoder that can be fed by the mock encoder, not by an actual compressed file. Right? And those symbols can then be fed from the mock decoder to the decompressor, meaning that we will be able to write the decompressor before we have the ability to read from compressed files. Okay, so that's the first step. Overall, I added multiple cards, right? So after implementing the mock decoder, we're going to implement the decompressor being fed by the mock decoder. And then when we're happy with the decompressor algorithm, we will create a byte-oriented decoder, which is the mirror of the byte-oriented encoder that we finished during the last stream. And with that, we would have a fully functional compressor-decompressor using a linear buffer sliding window. Okay, so let's go. Try this. That means that, I think I forgot about that. Yes, we need a new branch. New branch. This is for the multicoder. Okay, and here we obviously want to create a trait for the decoder, so we can have the mode decoder and then the second decoder, etc. So we're going to copy the encode trait into the decode trait. All right, so we have our trait, and we have something very interesting, is that the decoder basically is a very simple machine. It receives a symbol and it says what the symbol, and it does what the symbol says. If the symbol says here is a chunk of bytes, it writes a chunk of bytes. If it says a reference, you take a look at its window and go back to that position and copy exactly that amount of bytes, meaning that it doesn't need to know the minimums and maximums of anything, because all of that is just information for the encoder. Whether or not we need EOF, EOF end of file, that is still a thing, right? Because that depends on the configuration, and depending on the configuration, the decompressor may need to decompress until there is an end of file, or until enough bytes have been decompressed with regards to information that it has from other source about what was the original size of the uncompressed file, right? So this still needs to be part of our API for the decoder. But here's the thing. Now unlike in the encoder, in which we write a reference, write an EOF, write a literal, now the API for the compressor is asking the decoder, give me something, right? And it's not going to be give me a EOF or give me a reference or give me a literal, it's give me something. So for the decoders, we actually need to create a symbol enumeration. So the actual method for the code is the code, right? The code, decode the symbol, and is going to provide either an error, there is an IO error, for example. I don't know if that's still a thing, but let's assume that can be a thing. So a result of a symbol. Okay, and that's it. And that's the actual API. The compressor just asks, okay, give me a new symbol. And the decoder says, okay, here you have the next symbol, that is this or that or whatever. So as for symbols, we have obviously end of file. So this is a file enumeration. A reference. So I'm going to actually open the coder. That is implementation. I don't think we're in the derives. So we have the EOF. We have a tuple representing the length of the distance. But now we have a problem with the literal. You see, if the compressor asks the decoder for a symbol and the symbol is a literal, the symbol is not just a literal, it is a sequence of bytes that the decompressor needs to be put into the output buffer. So if we were to write the symbol like this, what would happen is that the decompressor would receive a literal with a vector, meaning that the data was in the input buffer, is copied into this vector, and then the decompressor needs to get this vector and copy it over the output buffer. So let's be clear, copying the literal block from the input buffer to the output buffer is something that I don't think can be prevented. Okay, so one copy needs to happen from the input buffer to the output buffer. But here we're copying from the input buffer to this vector to the output buffer. That doesn't make any sense. So how are we going to work around with that? So if I remember correctly, and I'm going to check off the screen what we did in the loss era. What we did is that the decoder was provided with a buffer, the chunk of the output buffer that could hold the copy of the input. That way we don't need to copy the data. We just need to provide the usize. Okay, is the amount of bytes copy the buffer. And what happens is that the decoder is provided with an output buffer. Which is I stopped streaming one day and I forget how to write the code. And slice. All right. That way, when we call the code, and I'm going to rename it because I actually like the name that we provided in the last era better. Next symbol. So it's the code next symbol, the code next symbol. When we call next symbol, the compressor receives a symbol saying EOF, so stop asking me for more data. Reference, so copy this amount that you have in your output buffer, this and that. Or literal, which is, okay, I just copied into your output buffer this amount of bytes. But here's the thing, that amount of bytes has to be bounded. It has to have a limit. So the output buffer also has a limit. So the compressor knows how much memory needs to basically allocate and have free in case there is a literal block. And that means that the decompressor actually needs to know the maximum length for a literal block, because that is going to actually be the size of the output buffer. So because it is only used for that, just let's call it like that. Returns the size of an output buffer that can hold the longest literal block possible. All right. So the idea is that the decompressor has an output buffer with at least this amount of size, calls next symbol, and then it receives either an EOF or reference or a literal. If it receives a literal, then obviously it needs to move the output buffer this amount of bytes, not this amount of bytes, because this is the actual amount of bytes of the literal block. All right, so that would be the API for the decoder. So now let's write a mock decoder. Sorry, we don't. We don't. because we call this the mock coder, right? So what we're going to do is that the mock coder is going to implement both the coder and the encoder. There is kind of a little reason for that. There can be a problem, a conflict with the meaning of symbol. We need to be careful about that. But they both have in common how they are configured. So the encoder config. And there is one function, right? The max leader length that is basically in common. And I don't know. I think that at the moment, having both of them in the same file, well, this file is quite long, but it can be useful, especially because that allows us to make tests, especially for the decoder, using the encoder. Okay, so we're going to do that. So we're going to define the mock decoder. Now, in the encoder was the owner of the writing. In the decoder, it should be the owner of the reader. Okay, but here's the thing. It could be a vector, because we're reading from it. It could be a slice. So what are you talking about? Let me show you. When we're implementing the constructor, do we pass along the reader as a vector? That could be a thing. Instead of the vector, we could just provide the slice. So the reader can have a reader be like that. And the reader is 0. And it's actually not. Yes, it's this symbol. Yeah. Okay, so the reader can have that. So when we write our testing software, we can just get the vector from the encoder that is not giving us a vector, is giving us a slice, and getting that slice directly into the decoder. The disadvantage of that is that because this is a slide, it's going to ask us for lifetime, going to ensure that it leaves. And to be honest, I don't think we actually need to work with that. Let me think for a second. You know what? We're going to make a vector. of symbols. And here we're going to receive an slice. And so that the reader is either on, I think. Right? So we create our own vector, even if it's kind of stupid because it's going to make a copy. But because it's a mock, let's keep it like that. Now, the configuration, we're going to keep it like that. And in fact, I'm going to, I think I can already remove this from the encoder. We will see, but I think that's the case. And needs lower. Now, you may be wondering, why are we doing that? Why do we need to construct the decoder with an encoder config when the only value that we need is max length literal? In my opinion, it's just to hide that fact, right? It's just in fact, what we're going to do is we're going to rename other config. So that way the user doesn't know the full picture. It just knows that it passes the same configuration for the as for the encoder, and the decoder works. Now, is the order of the arguments the same? No. So let's make things more similar. All right. The trade bound coder symbol is not satisfied the trade clone. Yeah, you're right. So we need to have the copy in the clone. So this one doesn't implement copy. All right, and now this works. So now we have our decoder that has the new. It receives the reader, and obviously it doesn't need to have an EOF. So it doesn't need to provide a result, because the result for the decoder is actually not in the decoder, it's in the decompressor, because the decompressor is just providing one symbol at a time. It's not accumulating things. So that's actually the implementation for the decoder, which obviously now is everything is not used, that code. So now let's implement the code for the code. So what we're going to do is we're going to use code, and we're going to use create create treat this different in me. Okay, so now the symbol that comes from the code, we're going to call the type decoded symbol, so we don't make a mess with this one here. And that means that this function doesn't return a symbol, but a decoded symbol. Right. So now let's implement needs_of, which is just needs_of, return get output size buffer, which is don't feed max length literal. And next symbol. Now for next symbol, uh, we need another thing. We need to keep track of the positioning on the vector. We could use, in theory, we could use pop. Let me show you. So when you push, you add symbols at the end, and when you pop, pop takes from the end. It should be then the back for it to work. So that means that we need to keep track of the input index. Okay. So we need input position, and the input position is integer to be 0. So obviously, we need to assert that the input position is less than set reader length, right? Because if we continue call next symbol when we are at the end of the buffer, that will ultimately fail. So that's the first thing. So now we need to have an encoded symbol, which is just set reader set input pos. Okay, so this is the current symbol that has been encoded that we want to decode. Mismatch types expected enumeration. Okay. So we have that encoded symbol. So now instead of just having the coded symbol, we can directly match and for symbol UF, we just need to return the coded symbol UF for symbol reference length distance. We just need to return the coded symbol reference length distance. And lastly, for symbol literal length, let's grab this into the A, so they directly work for the output. Perfect. So now, what about the literal? For the literal, remember we need to actually copy into the output buffer, right? So what we need to do is that the output buffer. Sorry, we need another debugger, so let's do that. Debug. In fact, this is not a debug. That could happen if in runtime. Let's keep it as a debugger. That the output buffer line has to be at least the equal to the, at least it needs to hold enough data for the buffer size. So this copy operation, we know that it's going to work. So we're going to make that the output buffer and between 0 and L is going to be equal, no, literal, so in, sorry, I'm not finishing any sentence, I'm sorry about that. So here in symbol, the literal receives directly a vector, so the actual data. So it doesn't receive a length, but the complete chunk. So we need to copy and then return the chunk length. Oh yeah, we'll call it symbol on chunk. I got the symbol into around how many times? Okay, and this quality doesn't work. The size for values of 8 can it be the left-hand side of the assignment must have a static input size. All right, so I will just copy in that just because So, oh, hmm. Okay, so basically what happened is that because I wasn't using, I'm taking a look at the old code, right? This is that because um, we never did the mock decoder. We just did a real decoder. The real decoder had as an input uh, an object that implemented read, so it could use read exact to copy data. So we need to know just how to copy process. Oh, clone from slice. Yeah, cool. So output. Oh, sorry. Okay, the chunk. Okay, clone from slice the chunk. Data move. Oh, cannot move out of index in the copy thread. Okay, let's try this first. Because I know that's something that's a problem. No, cannot move out. Ah, consider borrowing. So I consider borrowing. I'm making a mess of myself. Match and okay. That was, let's see. So now, okay, just copy this. Okay, and that is done. So that's our decoder. Is the mock decoder is as simple as that. The only thing that we need to do oh yeah, there's keep a couple things I think. let's copy something from the encoder. Documentation for the new, and let's write the documentation. So mock implementation for the coder. The coder keeps all inputs in great example is this coder. The coder will keep track of its COF argument, just behavior of write COF. No, it doesn't. Right? It changes the behavior of next symbol. Actually, because what it should do is here is that if EOF is a valid symbol, then definitely we should return and that symbol. But if that's not the case, we need to return the error. Do we have? Yes, yeah, supported. Now, this shouldn't happen, right? Because we're in the encoder. But if it happens, means that the encoder and the decoder had different configurations. So it's a good thing that we test that. Right? Big test. Quickly. Oops. Yeah. The decoder, yes. Perfect. All right, so that is all good and fine. We have finished the decoder except the tests. So the next thing that we need to do are the tests. But before that, I think it's due time for our stretch break. So let's do that. Don't forget also to hydrate, especially if, like me, you're under very hot weather. We'll see you in 2 minutes. And we're back. So let's do something. Let's run some tests. So for the decoder, we only need to write tests for symbol. So let's create a decoder. So the issue with the decoder is that needs to be passed along yeah, a slice. There's going to be copied, so there's no problem there. So we could do something like, for example, if we write symbol EOF for a decoder that has that doesn't need EOF, then we're going to assert that the decoder next symbol, we need a buffer. It needs includes buffer. And how do we know this long enough? Well, yes, we know, because it's it was created with a vector. Like this. Well, this it has a static size. Static is config max length right? And then for next symbol needs to be provided the output buffer as one slice. All right, so that is a next symbol. The input symbol is IOF, and we have configured no IOF. That should be an error. Arguments are incorrect. Expected neutral. Okay. You're right. And mock coder tests. Testing will work. Okay, perfect. And now we're going to assert that if we configure the coder to out of EOFs, then the output is going to be okay, or the coded symbol EOF. Oh, the coded symbol doesn't implement partial equality. Mm, I don't believe it that I stopped writing code for 2 days. I forget about everything. All right, so we cannot do it that way. So we need to put the coded symbol equals this. We need to insert first. The S is okay. Then insert the quality. The Pepsi. Okay. So this is each is most configure. This is EF test. This is reference test. And lastly, enter test. We are going to have literal with a vector use the vector again. with a vector of, let's say, 3, 4, 5, 6. And the coded symbol literal. Remember, the output only contains the size, the length, so it has to be a 4. And okay, let's agree. Oh. Return pattern. Okay. And is passing the vector as is. Let's take a slice and see if this works. We're going to assert that output buffer is equal to the contents of the button. Can't compare that to that. Consider the referencing here. No, that's a problem. It's very clear. Yeah. Yeah. So now we have successfully tested the mock. The mock decoder. So now the next thing to do would be to have an example of that. Now I don't want to do it in compress because this works as a real compressor if we use the other coder. And I don't want to use the encoder dump because I actually want to be able to debug with this one. So we're going to create a new example. which is write the symbols of decompression instead of the decompression of output itself. Main use for the unit purposes. So we're going to need all of these plus the over. And we're going to need the cosine. So we are going to create a configuration because it's going to be used both by the coder and the decoder. So we create a compressor, we read the standard input, we compress and we flash. And now, instead of writing the input symbols, which is what we had beforehand, now what we're going to do is we are going to create a decoder that is going to receive the result of the compressor encoder. And it's going to be configured also with between config. And now what we're going to do is create a loop, and we're going to have multi-coded symbol. Coded symbol be equal to coder index symbol. Obviously, for that we need the famous buffer. Let's not cost. And we'll create the buffer same way. Okay, here it is. So we're going to loop. We're going to get the next symbol. Each need to pass an uncommutable reference to the buffer. And we're going to unwrap and you're going to directly match. And in the case of symbol UF, we break. And in the other cases, not the other cases, because, okay. In the case of reference, you know what, we're going to break, but we need to print. And lastly, for symbol units around environment, we're going to print the literal. And that is going to be the buffer 102L. Keep asking. Okay. All right, so now with that, in theory, what happens is we read a file from a standard input, we compress it till the end, and then we decompress by hand. Because this is basically a decompressor, but it's not actually decompressing references because it doesn't have a window. But we at least decode each symbol, and then we print them out. Um, whoa, 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 whoa. So you see, there's a problem. There is a problem. Why? It should be calling again and again and again, not getting the next thing. Okay. Let's see. Equals please. No, it doesn't call again. Next symbol. And this is not a problem coming from here. mock coder. Sorry, mock decoder. Next symbol, get the symbol to be the one based on input position. Where do we change the input position? That's a bug. So because that's a bug, we're going to use another test, which is testing that input position moves. Okay, so this is as simple as we are going to assert that for this decoder that we have created and for which we have only encoded one symbol, that its input position should be 1. And now when we run the test, this fails. Okay, so now we have the bug. We have integrated the bug into our test suite, which is a very good thing to do, by the way. If you get the bug before you solve it, put the bug into a test. And now let's solve the issue. The issue is that, let's do that. We need to do that before the match. And here, don't care too much, so I'm going to open like that. So now the test. Wait. Oh, the length is 1, but the index is 1. Hmm? On line once line 172. Oh, oh my dear. Okay. Mm, mm, mm. So there are a few ways to solve this. The first one is to keep this in a reference before we increase input position. And I think it's the best one, actually. So let symbol be equal to this reference. Here's the reference. I'm not showing the symbol. Now this works. And now when we run, oh, perfect. Now when we run the example, it is also working. All right. So with that, I think we have managed the goal for the day. We have created a mock decoder with documentation. Okay, let's test that. So in the mock coder, now we have 3 structs, the decoder, mock implementation of the decoder, with the implementation of new. There's a type here. Why does it remove? Interesting. Fancy. Give me encoder. Lexing. Yeah, right. Perfect. Here's the behavior of this. Now thread implementation. How can we make it to go there, to go here, instead of going to the implementation? I figure it out. Not important at the moment. So I'm going to this. Even if it is not the correct thing, sorry, even if the link is at the moment broken, no, I see, that's fine. I got it. Yeah. But it's thinking to itself, not to next symbol. Struct decoder, not to method nexing. Right? Method nexing. Method dot nexing. Okay. Method dot nexing. Fine. Coder. Oh, okay. Hash. There it is. All right, perfect. Okay, so done. Config goes to color config. So the mock, the color is implemented, and the documentation for the tray. Perfect. All right, so we have made it, guys. So once again, I'm going to well, it's just a commit, right? And we have everything in a single commit. So I was going to do a git reset to continue editing the commit, but I think that if it's just for the comment, there was another command by git to just change the comment for the commit. This one. Minus minus minus. Hmm? Similar. So right, no decoder, and this names, how was it called? Encoder config config with implements with code tray doesn't implement these rights. Because traits and mock implementation. This is rename zero. So I think this is it. Cool. Let's take a look at that. Yes, that's correct. And this is this 7. So now we push it. And now we create a pull request. this called resolve issue 7. Right, the coder. Okay, and you just merge it. Perfect. So now if we go to the project, now the issue solved. And that means that tomorrow we're going to start with the next card. Which will be to write the decompressor. And I think that's all on my end. So tomorrow I will be streaming. We're going to work with the decompressor. I'm going to try, I need to learn to edit videos in YouTube, also for YouTube. And if I do that, I will create a video with the first part of this stream. So the presentation about dictionary encoding. And I will try to do a little bit more tests so I can avoid losing audio for no particular reason. I'm re-getting it back 11 minutes later, as it happened the last stream, or touching everything as it happened today. So I will try to work with that. With that being said, thank you very much for joining me today, or watching the video afterwards if you're taking a look at the VOD. This has been the Perfect Targent, signing off.